Texas, in some areas, is in a very wet weather pattern. We've got quite a bit of rain here in the region east of I-35. And this is about the first we've seen of any sun in the past day or so. Anyway, you can see lots of scud cloud there on the horizon, some of that rain about to clear out. And let's check out the surface map. And there you can see the outflow boundary across much of Texas, creating a bit of a cold pool from Louisiana to East Texas. We've got a very active polar front in Montana with a squall line that's going to be just west of Glasgow, east of Great Falls, kind of in that barren area there, north and northeast of Billings. Cold front extending down to the Wyoming and northern Nevada region, and some very warm conditions, lots of 90s in the higher terrain of Wyoming, all the way to the Wendover area in Nevada, where it's 94. In the eastern U.S., pretty quiet, starting to come under the influence of that very, very broad Bermuda high, and a stationary front there showing up in the Washington, D.C. area. Definitely is some interesting weather when you go north. Let's go to Hudson Bay, and they've got a pretty strong frontal system moving through there. Along the length of that, low 80s, very warm. And that's probably very uncomfortable, probably got mosquitoes really getting busy with that muskeg type terrain there. And we've even got 82 degrees way up there in Coudjouac community there in northern Quebec, located right there. And let's check out that picture. Yeah, a few trees actually. And the warmest temperature ever recorded there looks like that's going to be 92 with a July all-time high of 90, so we're quite a ways away from that. Definitely warm, and let me put those plots back on there. And you can see that 82 over 45. It's warm, but not really record-breaking. And out over the western part of the polar regions looks pretty typical for this time of year. We've got an enhanced risk for the high plains of North Dakota and Montana there. And definitely some storms going on. There it is, a fast-moving MCS. Looks like that's coming into the Glasgow area. There's the leading edge, and let's check that out on the satellite. Here's how things looked earlier this afternoon. This is going to be about 2:30 Central, 1:30 Mountain. We roll that forward. You can see the storms going up and anvils and overshoots moving rapidly eastward, and this is where we're at as of just after 6 p.m. Central. You can just pick out the overshoots there and find where the convective cells are, and some pretty good anvils coming out of that, even some gravity waves. So there is some definite punch to these storms here. And another cell further to the south. Let's go down there south of Billings. Pull that up here. That kind of looks like an isolated cell out there. Very good overshoots, very circular anvil there. So this has probably got some severe weather in it also. But, you know, that's out in the middle of nowhere. I don't think there's really any towns out there. Maybe Broadus. I don't really know the towns out there too well. There's an interstate that comes roughly like that, and all this is just barren. And it's kind of a tall order, even getting a road out there to get photographs. The radar, let's check that out. There's a look at the Glasgow radar. Checking out the squall line there in northeastern Montana. You can see just in that last frame there, just really jumped very quickly. And we can make out the outflow boundary right there. These cells are probably not tornadic or anything like that because the outflow is kind of gusting out ahead of them. These are definitely cold pool driven. And let's check out the spectrum width and see if we can pick out that boundary. Sometimes it picks it out, sometimes it doesn't. Here we can probably see a bit of a difference between this grayish color on one side of the boundary and the noisy clear air out ahead of it. Base velocity, sometimes it'll pick it out, and yeah, you can see that right there. Let's compare that with the reflectivity. So I've set that dot right there so we can check out the outflow boundary. And let's switch over to the velocity. And what we see here is red. Okay, we think back to our rule of thumb. Red, that's a warm color. That means outbound. So strong outbounds. Okay, something's wrong. You got to use that common sense when you analyze this imagery. Okay, let's go a little bit closer to the radar. Okay, green is inbound. That's cool shade. Red is outbound. Okay, so this is showing air moving southeast to northwest. But what about this here? This is actually aliased data. What's happening really is that there's outflow moving west to east, but the outflow is moving faster than the maximum unambiguous velocity of the radar for this particular VCP. And we can drag over this to kind of get an idea of what that maximum unambiguous velocity is. It looks like it's about 44 knots maybe. So the velocities in this are probably higher than 44 knots. We need to play around a little bit with the de-aliasing algorithm, and we find that right here. So we can change some of those values, and yeah, this looks better. I think there must have been some bad data in that. So now we hold down control and we see that there's inbounds of about 50 knots, 40 to 50. That sounds about right. That's some very gusty winds. 40 to 50 knots, maybe a few 60s. So yeah, this is definitely quite a haboob surging out from the storm, and I bet that looks very ominous if you were hanging around out in this region. Okay, further down the line, what have we got going on? More cells, but we can't really analyze the velocity here because we're going to be perpendicular to the radar beam. So anyway, let's go down to, I guess we're going to have to use the Billings radar. And there we find the tail end. The outflow definitely shows up very well. So even down there it is cold pool driven, and it looks like the bases are probably a little bit higher in that region. Now keep in mind the radar is right there, so we're kind of viewing it from the back. Going over to velocity, seeing lots of outbounds, but we got to keep in mind at this range we're going to be up at about 3,000 feet. So we're kind of getting up towards maybe halfway to 3/4 of the way up to cloud base. And all of that air is moving towards the east at about 30 to 40 knots. So it probably doesn't look like anything significant. And then, yeah, there's that storm there near Brodus. Take a look at the max tops on that, and we're getting into the 45 to 50,000 foot range. We are about 110 miles from that echo right here, up at about 13,000 feet, so we're in the cloud. Now we can look at the velocity to see if there's any mid-level rotation. And yeah, it looks like there probably is some. You can see there's some outbounds right here, some weak inbounds. We can move over to storm relative and get a look at that. Let's do that. Okay, I put in 270 at 25 for a basic movement, and I'm seeing maybe kind of a weak, broad inflow region right there, and some outflow there, so just kind of some convergence, maybe along that outflow boundary. Some, maybe a bit of rotation in there, but this is not tornadic. And then just checking the higher tilts for consistency. Nah, not very much going on. Okay, so that's going to be that storm there. The METARs for Glasgow, that's some pretty stout easterly flow there. Storm is not quite up to that location, but we're going to probably see a pretty impressive wind shift and winds howling out of the west shortly. Now, I think a very interesting thing to do would be to look at proximity soundings for the Glasgow area. So we're going to go up ahead of the squall line, and the model has already generated some convection in that area, so I'm going to skip back. And I think for that we're going to have to go back to a slightly earlier run. Okay, so now we can kind of analyze the environment in that area. So I'm going to skip forward. And I think that'll give us a good representation of what kind of sounding we have. So there we go. It looks vaguely like an inverted V. Definitely high-based. You can see the LFCs are up at about 2.5 kilometers. So that's definitely keeping the STP in the basement. Definitely some good instability there. 2,500 capes. No convective inhibition. Certainly no capping. And one thing that's pretty important is the decape, 1400. And the downdraft temperature is 55 degrees. So there, right there, you have the explanation for the strong cold pool being generated by this stuff. Some other numbers of interest. The downshear Corfiti vector, you can see that right here. It's that blue empty circle there. It's useful in forward propagating MCS cases like this, and that puts forward motion out of the, well, moving towards the northeast at 50 knots, which is about what the movement we're seeing is. There's the inflow vector right there from east to west, and that's looking about 20 to 25 knots of inflow. Right here you can see that. It's given about 20 knots of inflow, and all the parameters here are up in the severe category. These two are above the threshold, which the threshold is 15 knots there of storm relative motion. And this one, well, this doesn't really indicate storm severity, but indicates the class of supercell that we would see if storms were to become isolated, which they're really not. So, this does point to kind of like somewhere in between HP-ish and classic, but that's probably not going to mean a whole lot for a solid MCS like what we have right now. The environment definitely does show shear here. There's some long drawn-out shape on that photograph, and let's check out the bulk shear values. 33 for surface through 6, and the effective shear 30. It's not huge, but that's enough to keep the storms long-lived. So anyway, that's how we read the soundings, and if we're looking for tornadoes, we can basically just look at this and see the STP is very low. We can see the LFC is very high, which is detrimental, and then we can go through these coefficients here and find that LCL is working strongly against us. Same with SRH. I mean, there is some SRH, but it's not great. And bulk wind difference is kind of weak also. The only thing we really have good going for us really well is the Cape. Has the outflow hit Glasgow? Let's check it out. Refresh this. Yep, it hit. And there we can see 270 at 34, gusting to 47 knots. Multiply that by 1.15 and you have the miles an hour speed. So that's going to be 6 or 7 miles an hour on top of 47. That's about 53 to 54 miles an hour gusts. Very impressive. Lightning distant southwest to northwest pressure rising rapidly. And there it is. You can see the outflow overrunning the radar site. And probably the observation site is likely co-located. All right, so that's a thorough look at Montana. We've got to move quickly because we're already about 12 minutes into the weathercast and we got to get this uploaded. It does look like some action on the high plains, getting into kind of a midsummer pattern with lots of activity there in Colorado and New Mexico. And eventually we'll see that monsoon building into Arizona. We're getting into about that season. Showing a little bit of a forest fire there south of Reno, and I think that's about it for the southwestern U.S. Once again, Montana, very active frontal system through that area, and as we go west, we get more into the cold advection pattern. You can see some mountain wave activity and also some clouds banked up against the Cascades. We got thunderstorms throughout the northeast, starting with the Madison, Wisconsin area, west of Milwaukee there, and across Indiana, Ohio, and even up in the Montreal and Ottawa area. So lots of summer storm activity. No severe risks for that that really stand out. Yeah, just a little marginal there for Wisconsin. And then for the southeastern U.S., looks like a very tropical pattern there. And I can see a little bit of a circulation in there, so maybe kind of a tropical disturbance, kind of unsettled weather in that part of the country. Okay, our astronomy segment. Well, not much for this week, just Venus reaching its maximum illumination on Friday, and astronomy-wise, it will otherwise be a quiet week. And our quick geography lesson, the Adirondack Mountains. What is it and where is it? The Adirondack Mountains, those are going to be found in northern New York. That's located in this region right here. And you can see that's differentiated from the Catskill Mountains, which are further south. And the Catskill Mountains, that's more of a kind of a playground there for New York City. And we had Woodstock, which is located kind of in that area, or at least the Woodstock Festival. Actual Woodstock is kind of in this area. And then as you go north, Adirondack, they had the Olympics there back in the 80s, the Winter Olympics at Saranac Lake. And otherwise, it's a very remote, forested region. So the Adirondack Mountains, and what does that mean for weather? Well, not a whole lot. These are kind of low mountains. You can see the highest peak, 5,344 feet, and the rest of it's probably in the 3,000 or 4,000 foot range. But these mountains likely have somewhat of a blocking influence on polar air surges coming out of Canada. And that's about it for our webcast. I appreciate you all watching, and remember, we do count on your support, so if you're enjoying these webcasts, here's our Patreon. Send us a little bit of something, and I will credit you in the closing and on the credits. All right, time to get this uploaded. Thanks, and we will talk to you tomorrow. Bye-bye.